Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at graphing parabolas on their side. So they have equations of this form. This looks similar to turning point form for our usual parabolas, except the x and the y have been switched around. So for such an equation, the turning point is hk. This number outside the bracket is the x-coordinate of the turning point. As for the y-coordinate of the turning point, it is the negative of this number inside the bracket. So just be careful about that. Now, if a, this number out here, is negative, the parabola opens left, and if a is greater than 0, it opens right. If you have these two things, plus you also calculate the x-intercept, that will be enough to graph any such relation. So let's look at this example here. So the turning point here, the x-coordinate will be the number outside the brackets 3. The y-coordinate is the negative of this number, so positive 1. Now because a is 2, i.e. positive, this parabola is going to open to the right. And so now we just need to calculate the x-intercept. So if we let y equal 0, we have x equals 2, y 0 minus 1 squared plus 3, that just equals 5. So let's go ahead and plot those points. So the x-intercept will be here at 5. The turning point is at 3, 1, which is this point here. And because it opens to the right, it's going to go like that. Now, the turning point always lies on the axis of symmetry. It's just the axis of symmetry here is a horizontal line, whereas in normal parabolas, it's a vertical line. So because of the axis of symmetry, it's also going to go here. Just plot as many points as you need to graph. So the graph is going to look like this, a parabola on its side. Now, this graph does not constitute a function. We can see easily that it fails the vertical line test. That is, it is possible to draw a vertical line that hits the graph more than once. So what that means is, when you have such an equation, there are multiple x values that map to the same y value. So that's why I've been calling this a relation. It is not a function, because one input can yield multiple outputs. It is, however, continuous because there are no jumps in the graph. There are no places where the graph stops and then later starts again. All right, let's now look at doing the opposite, finding the equation when we're given the graph. So we're going to find the equation of this sideways parabola here. So we know, because it's a sideways parabola, we can write its equation in the form a times y minus k squared plus h. So we can immediately find h and k from the turning point. So h is the x value of the turning point, which is 1. And k is the negative of the y value of the turning point. So the y value of the turning point is 2. So we're going to put a negative 2 inside the brackets. So all that remains to be done is to calculate the value of a. So for that, we need another point. Any other point will do. I'll use this one, negative 2, 1. So I'm going to, into this equation, substitute x for negative 2 and y for 1. I then have negative 2, so x equals a, y minus 2 squared plus 1. So we do the brackets first, normal BIDMAS. So 1 minus 2 is negative 1, negative 1 squared is 1. I just get negative 2 is a plus 1, subtract 1 from both sides, a is negative 3. I've now found my value of a, and I already found my values of k and h. So I'm done. I just need to write the final equation, x equals a, y minus 2 squared plus 1. If I start with this equation, I'll end up with this graph. Once again, this graph does not constitute a function because there are multiple x values that map to the same y value. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.